Hello, students. Welcome back to Unit 2 Basic PLC Programming. In the last session, we saw three examples, and those were very simple examples. The first example was using one coil and one coil and one contact. That was quite a simple example. To begin with, I have taken the simple example. Then we went through a conveyor control application where I introduced seal contact concept to you. And then we saw a third example, which was standard start, which was standard forward and reverse circuit. So in the third example, again I introduced a new concept called the mutual interlocks. So these three examples were covered in the last session. So let me recap you what these two concepts are. A seal contact is used even though when the start button is de-energized, I like the function to be turned on. In that case, I need to use a seal contact, and seal contact it provides an alternate path, even though the start contact is opened. So, seal contact is always placed in parallel with the start button. This was evident in the last example we saw. Then I also introduced a new concept, a mutual interlock contacts. And sometimes what happens is there are two functions, and at a time only one function has to be turned on. In that case, we need to use what are called as the mutual interlock contacts, and this also I showed in the last example. So with these two concepts in mind, now we'll move on to other applications. So in this session, I'll be I will be describing instant forward reverse stop circuit. Then we'll move on to start, stop, and jog circuit. And at last, I'll be discussing about the alarm systems. So first, let us take instant forward reverse stop with direct reversal change circuit. In the last session, we saw that to change the direction from forward to reverse or vice versa, we need to press the or we need to energize the stop contact. So in that case, it was taking a time. So in some applications, we need a faster change of direction. So if it is go motor is running in a forward direction, then within a second or within a microsecond, within an instant, I need to change the direction. So I need instant change in the direction. So for that circuit, whenever I need very fast change in the direction, then I can use instant forward reverse stop circuit. Here you see here there are four switches I have connected. You have start forward switches here. You have start forward. So look at the connection diagram here. I have a start forward. That is to start a movement in the forward direction. I need to energize start F switch. Then If it is going in the forward direction, I need to stop. Finally, at the end, I need to stop. In that case, I'll be using a stop forward stitch stop F, which is connected between the terminals common and 1. Then to have motion in reverse direction, I need to energize the start switch, start R, and that is connected between the terminal common and terminal 4. And if the motor is running in the reverse direction, and finally at last I want to stop the reverse direction. In that case, I have to energize stop reverse switch, which is shown as stop R, and it is connected between the terminal common and terminal 3. Okay, then coming to this output side, here a forward drive for the motor is provided by the coil inside this PLC logic, and that forward drive coil is connected to here F. So this drive achieves or it tells the motor to run in a forward direction, and it's connected between the terminal common and terminal 17. Then R indicates it's a drive for reverse direction. So that is connected between the common terminal and terminal 18. In addition to this, at the output here we are using two pilot lights. One shows it's a red and the other is a green light. So red light is connected between terminal 19 and common, and whenever this pilot light is red light is on, it indicates that the motor is running in forward direction. And we have the green light connected between the common terminal and terminal 20. Whenever the green light is on, it indicates motor is running in reverse direction. Now let's move on to the ladder diagram here. Here we have IN002 contact. It is taken as normally open contact, and it is used to start a motion in forward direction. Similarly, I have IN001. This is normally closed contact. I want to stop the motor running in the forward direction. For this contact will be used. Then I have IN004 contact, and this is used to start the motion in reverse direction. And I have one more contact, IN003. This is normally closed contact, and it is used to stop the motor if it is running in reverse direction. So if the motor is running in a forward direction, then I have to stop it using IN001. And if the motor is running in the reverse direction and I want to stop the motor, then IN003 contact is used. Then we have a contact CR017, which is parallel with the IN002. So this CR017, it serves the purpose of a seal contact, which I explained in the last session. So CR017 and CR018 contacts are used as seal contacts. Because we call it a seal because it provides an alternate path even when IN002 and IN004 are de-energized. In that case, these two contacts will provide a alternate path. Hence, CR17 and CR18 contacts, they are used as seal contacts. Next, as I explained in the last session, motor can run in either one of the directions. It can't run at a time in both the directions. So that mutual interlock is needed. For that purpose, in the first rung, I've used a contact CR18 here. So CR18, it's a normally closed contact, and whenever this reverse motor is running in the reverse direction, this coil output will be 1, and that energizes the contact CR18, so it will be open. Thereby, the output of coil CR17 is 0. So in that way, it provides a mutual interlock. Similarly, here I have used a contact CR17. It is normally closed contact. So CR18 and CR17 contacts together provide you the mutual interlocks. Then here coming to the pilot lights, we were adding additional thing we have added here compared to your previous example. Here this red light is connected. Red LED may be connected to the contact. May be connected to the output coil CR19, and this 19 is connected in series with the output coil CR17 here. So CR17, that is when the motor is running in forward direction, the output of the coil CR17 is high, and when this high is applied to this contact, it will close. Thereby, this line will be completed, the rung is completed. So the coil 19 produces an output, and this will energize a red light. Similarly, when motor is running in reverse direction, the output of coil CR18 is high. And this high output, when I apply it to a contact CR18, this contact will close. So there is a connection between two rails, and this rung is completed. Therefore, the output of coil CR20 is high, and this will turn on the green light. Now, coming to the operation. So, I think now it's clear about the connections and the ladder diagrams and why I use the contact. The purpose of each and every contact is clear to you. Now, we'll move on to how we operate or how this ladder logic works here. So, as I explained in the beginning of the session, this is instant forward reverse stop circuit. So, instant means when there is whenever you want to change the direction of motion, in that case you need not have to operate a stop switch. So that's why it is called as instant forward reverse stop circuit. A stop is operated only when finally or at last you want to end the program. Only at that time your stop is operated. Otherwise, in between, that is to change the direction, I need not have to operate a stop switch. So this is the main difference between the previous example and this example. Now we'll see how this works. So first what I do is I will start in the forward direction. Then I'll change the direction to reverse. And at last I'll stop the reverse direction. First, here IN001, this is normally closed by default. So it will be closed. Next, I will start the motion in forward direction by energizing the contact IN002. So this contact will be closed. And then we have the contact IN004, which is start contact in this line here. So even this is also normally closed. I am not energizing it. Then we have the contact CR18. So anyhow, this output is 0. Therefore, we are not energizing the contact CR18. So it remains to be closed. So there is a a path, closed path between the two power rails, IN through IN 001, 02, 04, and CR 18. Therefore, a path is established between the two power rails in the first rung. Hence, there will be output at the coil CR17. Since a motor is connected to, or a forward drive of a motor is connected to this output coil, your motor starts running in the forward direction. So it has started running in forward direction. Suppose after some time I need to change the direction. So motor has to be made to run in a reverse direction. Now what I'll do is here I will not operate a stop switch. Instead, here you have IN004 contact. I'll operate this. I'll energize the IN004 contact now. Once I energize this contact, okay, when I energize this, this contact will be closed, and this 03 contact is already closed by default, and when I energize it 04, this will close, and similarly you have IN002, this is already closed. Then we have CR017 contact, which is driven by the output of the coil CR17. Since the forward direction is not is zero, output of this is zero. In that case, it will not energize this. Therefore, it remains the contact 17 CR17 remains to be closed. So there is a connection between two power rails in the rung 2, and this will energize the coil CR018. Therefore, a reverse drive which is connected to motor will be energized, and motor starts running in the reverse direction. When CR18 is energized, here you look at this coil contact CR018 in the fourth rung. So when it is running in the reverse direction, the output of this coil is 1, and this will energize the contact CR18 in the fourth rung. Thereby, you are energizing the coil CR20, and a green light will be turned on because it is connected to the output of CR20. So a green light indicates that a motor is running in the reverse direction. Suppose think that my entire the event is over, and at last I want to turn off the motor. In that case, if it is running in reverse direction, then I have to energize the contact 003. When I energize 003, this contact will open. Once this opens, there is no connection between the two rails. Therefore, the reverse drive will be de-energized. Thereby, your motor stops running. When this is de-energized, this contact, CR18 contact, will be open and green light will be turned off. So, so we went through like to start the operation. We have started the motor in the forward direction. It ran for, it remained in the forward direction for a certain amount of time. Then I changed the direction to reverse direction without operating these stop switches. So what I did is I simply uh, energized the start switch in the reverse direction. So here you can see here IN004, this start switch, it is normally open, whereas in the first rung I have taken IN004 as NC contact here. Which means that whenever the contact 004 is energized, here in the second line, when I energize, it closes. Okay, and in the first line, when I energize, it opens. Similarly, here you can observe the start contact in forward direction IN002. It is NO contact taken as NO in the first line, whereas in the second line, same IN002 contact is taken as NC contact. That is, whenever I energize, the contact in the first line, which is NO, will close. And at the same time, this contact IN002 in the second line, when I energize, it will open. So the two contacts, the same contacts are taken in two different lines. In one line it is taken as NO, and in the other line it is taken as NC. So whenever I energize, in one line it will be normally open, in other line it will be closed. So next we'll move on to the another example, a start, stop, and jog circuit. In real life also, in our daily life, jogging is a slow running. Running is you are running at a faster rate. Jog is you are running with a slow speed, with a lesser speed, or your jogging is slow running. Even jogging is also called as inching. So this jogging or inching of a motor means to have smaller movements of the driven machine. So a motor runs at a lesser speed. So jogging is also defined as a brief closure of motor logic circuit to energize a motor for short period of time and perform small movements of the driven machine. And where I use this jogging is a motor is jogged for following reasons we are jogging the motor. Like some machine parts I need to align. Other machine parts I need to align and space them. So in that case, a jogging is used, and I want to place the tool accurately. So I need a jogging there, and then to provide wherever I need to provide a small controlled movements, there also I need to use a jogging. And also jogging is used to thread a cloth, paper, or sheet of steel. So these are the typical applications where small movements of the motor is required. So technically speaking, the jogging is a momentary on control capability with one push button. That is, when I turn on the jog button, the motor should run at a slower speed, and this will allow me to align and space the machine other machine parts. And again, here coming to the jogging, sometimes in motor logic, we need to bypass the start button as well as the latching logic. This is for testing purposes. So I need to test something, a ladder diagram circuit, or I need to test. In that case, I need to bypass the start button, and in some cases I need to bypass a latching circuit. So at that point also, a jogging will be used, and to run the motor momentarily on, then I need a jogging. Now let's look at the pin diagram connections here. So here I have to start running. I want to start a run. I want to do motion in higher speeds. Motor has to run in high speed. So in that case, a start that is called run. So I need to start a run, and this is achieved using the start switch, and it's connected between the common terminal and terminal 2. Okay, then I want to jog, that is run at a lesser speed. In that case, this jog switch will be used, and it is connected between the common and terminal 3. And whenever I need to go from run to jog, run is one stage, jog is one stage. Whenever I need to change from run to jog, in that case, need to operate a stop switch here and connected between the common and terminal 1. Then I have a motor connected between the common and terminal 17. Now let's go to this ladder diagram here. Here you can see IN001 is a stop switch. IN001 is a stop switch. So stop is operated only when I need to change from run to stop. I need to change only when I need to change it from run to jog. Run to jog, I will be using stop contact IN001. Then I have IN002, which will make the motor to run. Then we have IN003, and this is used to start jogging. So to start running, I need to energize IN002, and to start jogging, I need to energize IN003. And in between, that is when I am going from run to jog, I need to use a stop contact IN001. Now we'll see the operation, and here this the first line, it is not an output, it's a intermediate output, and this intermediate output we are using here as a latch circuit. Okay, so this is normally closed. 001 is normally closed by default. Then I want first I'll start running. So motor starts running. So in that case, 002 is energized. So this contact will close. So we have a closed path between the two power rails. Hence, the output of coil CR110 will be energized. And when this 10 is energized, you have a contact CR10, so this contact will be energized, so it closes. And anyhow, the 001 is closed. This also closes. There is a continuous path like this in the second line. Thereby, a coil CR17 is energized, and a motor which is connected to the coil CR17 starts running. Now it is running at higher speed. Okay, now I want to change it to jog. In that case, first I need to operate a stop switch here. So first I have to stop running, and then I need to start a jog. So I will operate this stop here. So when I energize IN001, the contact will open. Therefore, the coil CR17 is de-energized and motor stops here. Now I will operate. I want to, now motor has to jog now. Now I will start jogging by energizing the contact 003. So when this is energized, it will close. So this is normally closed, and by energizing 003, we are closing this contact also. Thereby, your output of the coil CR17 is now energized. Therefore, our motor is also energized. Now it runs with a lesser speed. That is, it is jogging. And whenever I want to stop jogging, then I need to operate the stop button IN001. So now let's go on to an alarm system. Uh, Here the scenario first I'll explain. So actually this alarm system, there are four inputs. We have considered four input, and this alarm system means when if once input is on, input means it's an emergency input. So if one input is on, nothing will happen. And if any two emergency inputs are on, then a red pilot light has to go on. And if three emergency inputs are on, alarm has to siren. When all the four emergencies are on, then fire department has to be notified. This is a scenario in which your alarm system is working. Here you can see in the connection diagram, I have taken four inputs A, B, C, D. Okay. And here at the output side, I have connected a fire department notification, a siren, and then a red pilot light. These things are connected at the output terminals. Now we'll see the ladder diagram here. I say here it says that a red pilot light is on only when any of the two inputs are on. So here I have taken this one represents your input A, the contact 2 represents input B. Similarly, contact 3 represents input C, and contact 4 represents the input D. And here it is given that a red pilot light goes on when any of the two inputs are on. Any of the two input means it may be AB, AC, AD, or BC, BD, like that. So here I've taken a combination of two inputs, emergency inputs. So 1 and 2. When that is, here you can see here in this line, I have connected two inputs only when the red light goes on, only when both the inputs are on, both the emergency inputs are on. Therefore, the two inputs, two contacts are connected in series. So here 1 and 2, that is input A and input B may be on, your red light goes on. And in another combination, your input 1 and input 3, that is input A and C may be on. Even in that case also red light is turned on. Again input 1 and input 4, that is input A and input D, both are on. Even in that case also your red light has to um, be turned on. So like this uh, we have six combinations. So red light turns on only when any of the two emergency inputs are on. And in the third case, this alarm will siren only when any of the three inputs are on. So we have four combinations here. For to siren and alarm we are using four combination. It means that whenever I'm connecting these contacts in series, it means that all these three inputs are to be on in order to have the output turned on. And these three combinations, they are connected in parallel. It means that when any of these combinations occur, your output coil 18 will be energized. So this alarm siren will work when 1 2 3 input 1 2 3 are on, or it will work when input 1 2 4 are on. Your siren will produce a sound when 1 3 4, all the three are on. Your siren will produce a sound when all the three 2 3 4 inputs are on. So series connection of contact means that all these contacts have to be energized to produce an output at the coil. And when I connect in parallel, the contacts are in parallel means when any of these combinations turns on, then your output coil is also energized. And the last case is that a fire department is notified when all the four inputs are on. So in that case, here I have taken all the four inputs, and when all the four are on at a time, In that case your fire department will be it'll you will be sending a notification. So when all these four contacts are energized, then, or when all four emergency inputs are on, in that case fire department will be notified. So in this session, using the seal and mutual interlock concepts, we developed three more examples like instant forward, reverse stop, then jog circuit, and then alarm systems. So now let's quickly go for quiz section here. The first question is in standard forward reverse circuit, dash are used to ensure that forward and reverse outputs are not energized at the same time. So this is a question about the new concepts which I introduced in this session. So it is mutual interlocks. So mutual interlocks are used to ensure that both the outputs are not energized at the same time. The second question is in standard forward reverse circuit CR17, CR18 contacts are used as dash. So you have the output coil by name CR17 and CR18, and the contact is also given the same name. Contacts are given same name CR17 and CR18. It means that whenever the coil 17 is energized, this will energize the contact CR17 also. Uh, so if it is normally open, when it energizes, you will be closing it. So here in this example, CR17 and 18 contacts, they are used as interlocks. Interlocks is two inputs cannot occur at a same time. Then a third question is what is a jog? Options A, condition wherein two outputs are not energized at the same time. B, momentary on capability with one push button. C is condition wherein output coil is energized even though start button is released. D is none of the above. So the answer is jog is momentary on capability with one push button. And here we have condition wherein two outputs are not energized at the same time. This is called as mutual interlock. And condition wherein output coil is energized even though the start button is released. This is called as a seal contact. So the momentary on capability with one push button is known as a jog. Fourth question is what is seal contact? A, condition wherein two outputs are not energized at the same time. B, momentary on capability with one push button. C, condition wherein output coil is energized even though start button is released. D, none of the above. The answer is condition wherein output coil is energized even though start button is released. And this is called as sealing concept. Thank you.